This is JEE 2020 Advanced Paper 2 of Physics. In this section there are 6 questions, all single digit integer type question with -1 marks. So let's start our video right after this short break. And if you are first time on my video, then please like, subscribe and don't forget to hit the bell icon button to get the video first.
Audio Jungle. Audio Jungle.
Question number 1. A large square container with thin transparent vertical walls and filled with water, refractive index 4/3, is kept on a horizontal table. A student holds a thin straight wire vertically inside the water 12 cm from one of its corner as shows schematically in the figure. Okay. Looking at the wire from this corner, another student sees two images of the wire located symmetrically on each side of the line as shown. The separation in centimeters between these two images is. Okay. So the side view is over here and here this one is 12 centimeter. In this situation here two different cases can be arises. So in this question some ambiguity is there. If you see, then means if you consider a perpendicular situation, means rays is incident normally on the surface, then we will get the answer 3 over here, and otherwise we can get the answer 4 or 5 is also there. So you can write over here the answer as single digit type of integer type question. So you can write over here 3, either 4 or 5, 3 different options are there. According some ambiguity is there and officially it's also yet not correct. So let's see about this. So we are quoting the result as 3 and considering perpendicular. Although we'll discuss for 4 or 5 also justify our answer. So let's start. If we draw the schematic diagram here, so this is OI and let this be J, this be M, and here drop the perpendicular, that is N, this length. And let this other position is L and N. So OJ upon 12, if you see here, that is cos 45 degrees. So OJ you can see in this way you can find the real depth that is 12 by root 2. Okay. And as you know, that is apparent depth upon real depth, that is, as you know, that is 12 by root 2. So 3 by 4 is here. So apparent depth will be that is mu, as in the question that is given here. So apparent depth is equal to 3 by 4 into 12 by root 2, and that is equal to 9 by root 2. In this way you will get OI. So OI will be 12 by root 2 and minus that is apparent depth, that is 9 by root 2. So 12 by root 2 minus 9 by root 2, that will be 3 by root 2, and that ON, that what do you call here, if you see here, that is ON, this one is ON. So ON you can find 3 by root 2 into 1 by root 2, cos 45 degree, that is 1 by root 2, and here that will be 3 by 2. So the final result will be 2 times of 3 by 2, that is the answer is 3. Okay, so this is the 3 for justification of the answer 3. So we are writing here 3, and for 4 or 5 if we dictate over here, so we will justify this answer also. We'll use the formula h equal to n square h cos cube theta upon n square sin square theta to power 3 by 2. This formula we have already derived in classes, if you see. So here this is the surface and the line of sight is over here. This is at A point, and that is this one is real depth and that is apparent depth. So due to this one, let this be, as you know, this is the theta incident ray from vertical. So L equal to, you know, that is H tan theta 1 minus H dash tan theta 1 here. So if you see over here, you can find the value of H, that was we have in the previous we have already find 12 by root 2, and here that is so submit these values, theta that is 45 degree over here. So that we say, and mu1 sin theta 1 is equal to mu2 sin theta 2 from air, that is 1, and refractive index denser medium, that is for this one. So we are writing over here 4 by 3 as 1 sine theta 1 into, for this one, with respect to, means this one with respect to air. So that was theta 3 by 4, and now we have to write for here 4 by 3 into sine theta 1 into, because light goes from dense to rare like this way. So sine theta 1 is equal to, we say 3 by 4 root 2, and nearly this is the value 32 degree you can say, and that is tan theta 1, that is 0.62. So n, that is 4 by 3 as you know here. So theta will be 45. So answer will be here 12 by root 2, and submit these values over here in this result, that is n square h cos cube theta upon n square sine square theta or 3 by 2. You will get these all the results, nearly 3.7 centimeter. That is the h dash distance. And here now L equal to 12 by root 2 into 0.62 minus 3.71. You can see this one. And after calculating, you get this result. That is 2i nearly. That is this one. So the result will be, finally you are getting 4.56. So you can write over here 4 also or 5 also. So there is some ambiguity is there, you can see. So now let's go to another question. Question number 2. A train with cross section area ST is moving with speed Vt inside a long tunnel cross section of area S0. Assume that at almost all the air density rho in the front of the train flow back between its side, the wall of the tunnel. Also, the airflow with respect to the train is steady and laminar, take ambient pressure, and that inside of the train to be P0. If the pressure of the region between sides of the train with the tunnel walls is P, then P0 minus P is equal to 7 by 22n, means 2n is given, and rho Vt square. Then you have to find the value of n. This n you have to find. So let's see. As you know here, so applying the equation of continuity here, that is A1 V1 is equal to A2 V2. Here that is, let the area of cross section, this one is 4s is what it was given here, and let this be ST. So A1 V1 A2 V2 apply, we get the value Vt over here. Now applying Bernoulli Theorem, P plus half of rho V square dividing with rho, that is and you get, so, and rho GH, as H both heights are constant, so H we are not using over here. Rho GH is potential energy equal. So after dividing rho, you get P by rho V square by 2 is equal to P0 by rho and Vt square by 2. So substituting these values, so put the equation 1 here in this equation number 2. So you will get P0 minus P is equal to 7 by 18 PVT square. In this way, you will get 7 by 2n rho Vt square. So that is n is equal to 9. Submit this value. So that's your answer. 2 and 2 related, that is 2, 9, 18. So 9 is the answer. Okay, let's go on another question. Question number 3. Two large circular discs separated by a distance of 0.01 meter are connected to a battery via switch as shown in the figure. Charged oil drops of density 900 kg per meter cube are released through a tiny hole, this one, at a center of the top of the disc. Once a small oil drop achieves terminal velocity, okay, the switch is closed to apply a voltage of 200 volt across the disc. As a result, an oil drop of radius 8 into 10 power minus 7 meters stops moving vertically and floats between the discs. The number of electrons present in the oil drop is, neglect the buoyancy force, take acceleration due to gravity 10 meter per second square. Okay, the charge of an electron is given 1.6 into 10 power minus 19 coulomb. This is the schematic diagram. Switch is given, circuit is given over here, 200 volt, and this separation is 0.01 meter. Okay, so let's start. That is the here QE equal to mg, electrostatic force QE, and the weight was mg. Substituting this value, you can get the value of Q here, and quantization of charge, Q equal to Ne, so N is equal to Q by E. Substituting these values, you get N equal to 6 after some calculation. Okay, let's go another problem. A hot air balloon is carrying some passengers and few sandbags of mass 1 kg each, so that its total mass 480 kilogram. Its effective volume given the balloon is, its buoyancy is V. The balloon is floating at the equilibrium height of 100 meter. When n is the number of sandbags thrown out, the balloon rises to a new equilibrium height closest to 150 meter with its volume V remain unchanged. If the variation of the density of the air with height h from the ground is rho of h is equal to rho naught e to the power minus h on h naught, rho naught is given, that is 1.25 kilogram per meter cube, and h naught is 6000 meter, then the value of m is. Okay, so you see here, this is mg equal to fu. Now, as the value of m was here 480 kilogram, and this one sandbags of masses are 1 kg. Okay, we'll later on use. So 480 into 10, g was 10, the rho gv you can find, and this you say rho equal to rho naught e to the power minus h by h. This formula you can use over here. Rho is equal to rho naught e to the power minus h by h naught. It is given. So submit those values, and here that is rho power 1 means that is and what we see over here, 480 minus n into 10 is equal to rho naught e to the power means 100 upon 6. This one for this is the second equation for 6000, and when it was 100, so 100 meter. This was a 100 meter. Now when n is the number of sandbags are thrown out, the balloon rises to the equilibrium of 150 centimeter. Means we are now you have to reduce some masses, and the height increases to for 150 meter. So when we make here 150 meter, so you have to reduce this. Let n be the number of bags in the sand. So 480 minus n, then you can find this new rho dash somehow. So for this rho dash, using the same formula, rho naught e to the power minus h by h naught. So that is 150 upon h naught. The two cases arises, 1 and 2. And now dividing this equation, you can get the value of n over here. It's a simple problem. Now come to the question number 5. Point charge q of mass m is suspended vertically by a string of length L. A point dipole of dipole moment P, okay, is now brought towards Q from infinity, so that the charge moves away. The final equilibrium position of the system, including the direction of the dipole, the angles at the distance is shown in the figure below. If the work done in bringing the dipole to the position is n into mgh, where g is the acceleration due to gravity, then the value of capital N is fill in the blanks. And here you have to note that the three coplanar forces keeping a point mass in equilibrium is f upon sine theta. Whenever there is a three coplanar forces and there is an equilibrium, then you have to use here Lamy's theorem. So Lamy theorem will be applied over here, where f is any one of the forces and theta is the angle between other forces. So the strategy is here applying Lamy theorem after making a free body diagram of this this one system. So let's start the solution. Here what happened, this weight mg is acting over here and tension T, and due to this F electrostatic force, F, that is 2k pq upon d cube. This is force is there. So this body is suspended under the action of three forces. So here later on we will use Lamy theorem, but before this consider the angle, because while applying the Lamy theorem you have to consider this one angle also. So let this angle be beta from vertical. This one is beta, and so here you see alpha, and let this be alpha. So alpha, this one is alpha, let's say, and this one is beta. So exterior angle is equal to sum of two interior angle. You know, this is alpha plus beta, and this is also, let's say, this is beta. So that it means, as this one is isosceles triangle. This is L, then this is beta. So alpha plus 2 beta, that is pi. Now beta equal to, you can say, pi by 2 minus alpha by 2, and here the weight W equal to mgh plus kpq upon d square. Now apply over here Lamy theorem, T upon this T opposite angle, that is opposite to the angle between this one mg and f, so we use sine alpha plus beta, and mg upon sine of, once again, that is alpha plus beta, and here this one force acting, f upon sine 2 beta. Now equate one by one, here there is two equations, so mg upon sine pi by 2 plus alpha by 2 means substituting this one beta, that is pi by 2 minus alpha, so we will get pi by 2 plus alpha, and hence we can get here 2kq pq upon d cube sine pi minus alpha. For beta, submit this value over here. So what we get here, mg upon sine 90 plus theta, you know that is cos theta, so that will be mg cos alpha by 2, and here sine 180 minus theta, that is sine theta, so that will be sine alpha. Now solve, added this one, another equation, and here that we say, if you see kpq upon d square mg sine alpha d, so submit these values, and here mg sine alpha into 2l sine alpha by 2 into 2 cos alpha by 2. So you can evaluate it, and after this applying this sine alpha, you can say 2 sine theta by 2 cos theta by 2, cos theta by 2 related later on, and here that is one of this one cos theta by 2, this one related, and hence we find 4 mgl sine square alpha by 2 upon 2, and finally 2 mgl sine square alpha by 2 related with to this. So finally what we get here, cos beta is equal to h by d. So that is cos beta is equal to h by d, and d was, that is of course 2l sine alpha by 2. Now here submit the value beta, what we operated over here, beta that was 90 minus alpha by 2, submit this value over here. Cos 90 minus theta, once again sine alpha by 2, and cross multiply, you get sine square alpha by 2, that is h.2l, and hence we can say you can evaluate this value. Now submit this value of sine square alpha by 2 is equal to h upon 2l over here. For this sine square alpha by 2, we can solve this, and in this way we can get kpq upon d square. So let's remove this with this one mgh, and hence we get n equal to 2. So w is equal to 2 mgh, and hence n is equal to 2. Let's go for another question, that is question number 6. A thermally isolated cylindrical closed vessel of height 8 meter is kept vertically. It is divided into two equal parts by a diathermic, perfectly thermal conductor, frictionless partition of mass 8.3 kg. Thus the partition is held initially at a distance of 4 meter from the top, as shown in schematic below, figure below. Okay, each of the two parts of the vessel is 0.1 mole of the ideal gas of at temperature 300 Kelvin, and the partition is now released and moves without any gas leaking from one part of the vessel to the other. When the equilibrium is reached, the distance or the position from the top in meter will be, take the acceleration due to gravity 10 meter per second and universal gravitation constant, that is gas constant, sorry, 8.314 is the 8.3 joule per mole per Kelvin. Okay, so what we have to do? Initial condition, here you apply this one, two different gases are there. So PA into 4, that is 0.1 R 300 for both the partitions A and B. After release for A, so PA into A is equal to X, let this equation number 2, and for B, that is PB A into 8 minus X, that is means, so at equilibrium that PA plus mg is equal to PBA, weight mg was the mass of gas is 8.3 g, so PAA plus 8.3 g, that is PBA. Now put the value of equation 1, equation 2 from equation 3 in equation 4. So in this way we get y square minus 2y minus 24 equal to 0. So after solving, you quadratic question, you can get the value of y equal to 6. Although here also some ambiguity is there in the question, but official answer they claim that y equal to